Here's a typical word problem you'll see. They'll say something like the height of an object follows this path. Find the point when it's at its highest and the time. So find its height and the time, and then also find when it hits the ground.
Okay.
So this is a classic example where you're going to take, if you imagine this, there's a negative leading coefficient and it's a quadratic, which means it's going to do something like this. And that's the point that I want to find, and that's the time. So this is t comma h of t for your height, and this right here is going to be when it reaches the ground. This is when t equals, that's when the height equals 0. See how the height's 0 right there? So this is your h of t and this is your t, and so they want me to find basically the vertex, and they want me to find the x-intercept, and then interpret those results. Well, to solve this, I have three choices. Let me start over. To find the vertex, I have two choices.
Okay.
I could either complete the square and put it in vertex form, which is not easy because that's a crazy number, and that's going to be, I'm going to have to factor out a -7 out of there. It's going to be messy. Or I can just use the good old standby of -b over 2a, comma, whatever. So -b over 2a, that's my vertex. So let's just do that real quick and so you can see how easy that is. So the vertex is going to be -30 over -14, which reduces to, take half of both of them, -15 over 7. I'm sorry, +15 over 7. That's your vertex, right? So this point right here, I'm sorry, that's your t coordinate. That's the time.
That's the time.
It's 2 1/7 seconds. See how much easier that was than trying to complete the square. Well, now to find the other part, to find the height, all I have to do is plug this back in, and since we have calculators, it's not hard to do.
Okay, so that's all you have to do to find the y-coordinate.
That's all you need to do to find the y-coordinate, because you have the x-coordinate.
Okay.
So now you need, or the t-coordinate, now you need the y-coordinate. Now I want you to notice something else. So let's talk about how you would find this point right here. I'll do this in orange. How you'd find this point right there.
Okay.
Meaning the 0. When does it hit the ground? So this is just like the vertex. There's a couple ways I can do it. I can either complete the square, which we just talked about is not a good idea, and then remember I want to set 0, y, or h of t equal to 0. Completing the square isn't going to work very well. Does it factor?
No.
That doesn't really look like it factors. You could use your calculator and trace it maybe, but they might not. They might want to see the work. So the work is going to be this, -b, it's the quadratic formula, plus or minus the square root of b squared minus 4ac all over 2a. So that's actually probably the route that I would take to do this.
To find the zeros?
To find the zeros, use the quadratic formula. And let me point something out to you about the quadratic formula. See that right there?
Yeah, that's the vertex.
That's your vertex. See that?
Yeah.
And see that right there? You're adding that distance right there is actually the square root of b squared minus 4ac. That's what that distance is.
Okay.
So technically, if you wanted to, you could just find the discriminant right here. Take the square root of it and add that to
the vertex,
the x-coordinate of your vertex. Technically, that's all you'd have to do.
Okay.
I'm sorry, I lied to you. You would have to divide that by 2a, because if you did that, it would be b squared minus 4ac all over 2a. So if you wanted to, you could just find that coordinate, or that right there, and add it to the what was it, 7 and the 7? 15 sevenths?
15 sevenths, I think, yeah.
So you could, if you wanted to make it a little bit easier, you could just calculate that.
Okay.
Or you could just punch this in your calculator and be really careful with it, or use a formula if you have a calculator that's got a program that already runs that. That's a good way to do it as well.
Okay. So all I have to do